a groundbreaking image of the interstellar Comet 3 I/ATLAS has unveiled peculiarities that defy conventional expectations. Researchers have observed that solar radiation interacts with this celestial body in an unprecedented manner, distinct from any previously documented phenomena. Captured by the Mastcam-Z instrument aboard NASA's Perseverance rover on the Martian surface, the photograph depicts a subtle, hazy blotch against the red planet's sky. This marks the anticipated position of the interstellar interloper 3I/ATLAS, providing humanity's inaugural close-range glimpse from another world. In the frame, the comet manifests as a dim streak adjacent to faint stellar points, each registering around magnitude 8 in brightness. Supplementary telemetry indicates motion in the Martian atmosphere, which experts attribute to the approaching 3I/ATLAS itself. Notably, this snapshot was acquired just prior to the object's nearest passage by Mars, as surface-based assets like Perseverance could not align perfectly for the optimal moment. Orbiting observatories around Mars were better positioned for precise imaging during the closest encounter on October 3, 2025, at approximately 0.19 astronomical units, or about 28 million kilometers, away. However, ongoing U.S. government operational constraints may delay the dissemination of high-resolution orbital data from NASA missions. Coinciding with this flyby, Perseverance documented heightened geological unrest on Mars, including swirling dust vortices near the rover and an expansive dust plume emerging on the distant horizon, potentially influenced by the comet's gravitational or atmospheric perturbations. The comet's tail, a hallmark of solar system comets, eluded detection in these ground-level views due to its feeble intensity at that juncture. This absence of a prominent tail is atypical, as most comets exhibit robust extensions of gas and dust under solar heating, as 3I/ATLAS drew nearer to Mars. Preliminary signs of a slender, underdeveloped tail emerged, yet it remained exceptionally faint and attenuated compared to terrestrial analogs. Additional unverified imagery hints at an oblong morphology, evoking similarities to the inaugural interstellar visitor 1I/Oumuamua, rather than the more rounded 2I/Borisov. Propelling forward at speeds exceeding 200,000 miles per hour, 3I/ATLAS is en route to its perihelion, the innermost solar approach, anticipated around late October 2025. The narrative shifted dramatically when astronomers posited that a coronal mass ejection, a colossal expulsion of solar plasma and charged particles, may have intercepted the comet. This event likely exacerbated its fade from visibility, compounded by escalating distance and solar glare, with Earth receding in the opposing orbital direction. Consequently, 3I/ATLAS will evade observation until its post-perihelion reemergence later in 2025, traversing constellations such as Virgo and Leo. What initially seemed an ordinary transient has since revealed structural and optical irregularities that upend established comet paradigms. Pioneering polarimetric analysis of 3I/ATLAS has yielded transformative insights. Sunlight traversing the vacuum scatters upon encountering cometary particulates, with each dust mote or icy fragment refracting rays in multifaceted patterns. This diffusion organizes light waves, aligning them preferentially, a process termed polarization. By quantifying polarization degree and orientation, scientists discern particulate attributes, dimensions, contours, textures, and constituents like silicates, organics, or volatiles. Conventional comets display positive polarization at expansive phase angles, the Sun Object Observer geometry, and negative at narrow ones. For 3I/ATLAS, observations via telescopes, including the Very Large Telescope, yielded an extraordinarily potent negative polarization, peaking at -2.77% at a mere 6.4 degrees phase angle, unrivaled in the annals of comet studies. This aberration implies dust grains of aberrant irregularity, coarseness, or exotic makeup, alien to solar system comets and even prior interstellar sojourners like 2I/Borisov. Such traits evoke formation in frigid, disparate environs, perhaps the outskirts of another stellar nursery or primordial galactic core, predating our solar system's 4.6 billion-year lineage. Spectroscopic surveys further disclose a compositional quirk, environs mirroring Mars' thin CO2-dominated atmosphere and regolith, intimating origins not from icy belts, but a planetary crust akin to our neighbors. Anomalous luminescence, including a verdant hue sans typical dicarbon emitters, foreshadows volatile instability near perihelion, risking fragmentation or hyperactive sublimation. Compounding enigmas, 3I/ATLAS, exhibits mass efflux via a nebulous gas envelope, yet its trajectory remains unswayed by outgassing recoil, contrary to cometary norms where vapor jets induce perturbative thrusts. Astrometric compilations from global observatories cap non-gravitational deviations below 15 meters per day squared, necessitating a nucleus mass surpassing 33 billion tons for equilibrium. At comet-like densities, this equates to a core exceeding 5 kilometers across, dwarfing predecessors by magnitudes and straining interstellar rocky inventories, statistically improbable without invoking denser, engineered constructs. Iron-nickel abundances in its coma further deviate, evoking metallic anomalies over pristine ices. Harvard's Avi Loeb categorizes these idiosyncrasies into resolvable and perennial puzzles. Provisional oddities encompass its bulk, an atypical anti-tail, sunward dust jet elongated 10:1, aberrant chemistry, and polarization extremes, potentially clarified by forthcoming Mars orbiter scrutiny. Enduring conundrums persist. Ecliptic alignment within 5 degrees, 0.2% odds, synchronized planetary grazes, Mars at 0.19 astronomical units, Venus-Jupiter proximities, 0.005% probability, and directional concordance with the 1977 WOW signal, a 72-second radio burst from Sagittarius at right ascension, 19 hours, 25 minutes. Declination minus 27 degrees. To within 9 degrees, 0.6% chance. In 1977, 3I/ATLAS lingered approximately 600 astronomical units distant, capable of emitting such a hydrogen-line blue-shifted pulse via gigawatt-scale transmission, akin to nuclear reactors, though unverified. Loeb contends that naturalists must substantiate these alignments via prosaic mechanisms, lest artificial provenance gains traction, echoing Oumuamua debates. As 3I/ATLAS hurtles onward, unthreatening Earth at minimum 1.8 astronomical units, it embodies a galactic emissary, urging vigilant spectroscopy, polarimetry, and radio monitoring to decode its genesis. This transient probe into extrasolar realms may redefine cometary diversity, hinting at alien planetary architectures or, provocatively, engineered relics probing our cosmic solitude.